distribution of electrons into orbitals of an atom is called its electronic configuration. As per the above principle, whatever I discussed in the previous class number 41, that when electron will fill up, then electron will enter first 1s orbitals, and this orbital maximum capacity of entering electrons is 2, and then as per the higher energy level, next level is the 2s. 2s means 2 is the principal quantum number and s is the sharp shell as per the azimuthal quantum number, what I already discussed. So here, for the order of filling of the orbitals, it will come in this way: first 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 4d. In this way, the electrons will be filled in orbitals. Now we'll see the electronic configuration of atoms. If you go for hydrogen atoms, we know that it has only one electron, so its configuration will be written as 1s1. That means 1, it is for the principal quantum number, and it is a shell, and subshell is s, and superscript, it will be 1, because electron is 1, so we have to write. This way we have to write for the electronic configuration atom. So for helium, we know that helium has 2 electrons, and it will be occupied by the number 1 shell, and subshell is s. So 1s superscript 2. 2 means 2 electrons. That means the number of electrons will be superscript of the sharp shell. In this case, the sharp shell is s. So if you go for the lithium, then lithium has the 3 electrons. And one thing we have to remember, that box form, when we write, then you see this electron as per the spin quantum number, it will be in opposite direction. One is the upward and one is the direct downward arrow. So in this way we have to write, because then only these electrons will be paired. So lithium has 3 electrons. So electron configuration will be 1s2 and 2s1. And these 2 belongs to the 1s. I have written down. So 1s superscript 2, and this electron for lithium, this electron occupied by the 2s orbitals. So 2s, and superscript is 1, because this electron is 1. So if you go for beryllium, then both 1s and 2s is occupied by 2 electrons in each case, and in this way we'll find its electronic configuration 1s2, 2s2. For boron, it has 5 electrons. So first 1s and 2s, in that case the 1s2, 2s2. Now when p subshell has come, we know that p subshell has 3 orbitals, px, py and pz, and in this case the px will be occupied by 1 electron in addition to the 1s2, 2s2. So whole electronic configuration for boron is 1s2, 2s2, 2px1. And next, the carbon. So for carbon, it is the 1s2, 2s2, already it is there. And this 2px and 2py, both are half filled. That means both will have the single electron only as per the Hund's rule, whatever I discussed in the previous class number 43. It will be half filled. So 1s2, 2s2, 2px1 and 2py1. For nitrogen, nitrogen has the 7 electrons. So 1s2, 2s2, it is already there like beryllium. And then the 3 electrons in p orbitals, 3 p orbitals. These 3 orbitals each have only one single electron. So it is the 2px1, 2py1 and 2pz1. In case of oxygen, so 1s2, 2s2. In this case, the 4 electrons in p subshell. So one orbital px will be paired with 2 electrons. So in this case, it is the 2px2, 2py1 and 2pz1. Similarly, for fluorine, you can see that 1s2, 2s2, 2px2, 2py2, 2pz1. So it will be written as in this way. So when neon, in case of neon, all 1s, 2s, 2px, 2py, 2pz, all are filled with 2 electrons in each case. So we can write its electronic configuration 1s2, 2s2, 2px2, 2py2, 2pz2.